Hey folks, let's take a look at the next figure in our study. This is going to be ellipses. This is from the notes from section 7.2a. First thing I want you to notice is that I have two different ellipses. One of them is a horizontal ellipse, and the second one is a vertical ellipse. Each ellipse has the exact same types of pieces, so I'm only going to fill them in on the horizontal ellipse. The first thing to notice in the horizontal or either ellipse is that I have my center. Once again, I'm using that coordinate HK. So this is going to be the center of my ellipse. The next thing to take a look at is that my ellipse has a major axis. The major axis is that axis that runs through the entire thing, and it's the long one. In the vertical ellipse, it's this one right here. So the major axis is the one that's long. And then the minor axis is going to be the one that's short. It's the other axis. On the major axis, I have 2 points. Each of them is called the vertex, and it's a turning point, much like it was back in the parabola. I also have the, notice that the vertex is the end of the major axis. I also have something for the end of the minor axis. And I have no special name for that. It's literally just called the end of the minor axis. The next thing I'd like for you to notice is that the ellipse also has a focus. Actually, it has 2 of them. 2 focus points. The next thing to notice is it's 3 different distances that I want you to pay attention to. The first distance is this one right here. It goes from the center to the vertex, and that is going to be a distance of a. And you'll see that here in just a moment in our standard equation, a distance of a. The next distance to pay attention to is the distance that goes from the center to the end of the minor axis, and this is going to be a distance of b. And then the last distance to pay attention to goes from the center to the focus, and this is going to be a distance of c. So now let's head to our standard equations. Notice that on our standard equations, the numerators are identical. So I'm starting with an x minus h squared and a plus a y minus k squared on both of my equations. Those are no different. However, what is different is going to be the denominators, my a's and my b's. Remember that the a is on the major axis, so the a value is always going to be longer than the b value. So in English then, what I'm really looking at is that in this equation, the larger denominator is under the x's, and on my second equation, the larger denominator is under my y's. So when the larger denominator is under x's, I have a horizontal ellipse. It's running along the x direction. When the larger denominator is under the y's, I have a vertical ellipse. It's running along the y direction. I've already made mention that a is always greater than b because a is on the major axis, b is on the minor axis. This next little formula, a squared minus b squared is equal to c squared, I'm not going to use it in every single question that I do regarding ellipses, but I am going to use it anytime I need to know something about the focus. So a lot of times I'll call this equation the little dude. Couple of more comments here, and I've already made mention of this. A is always regarding the major, B always has to do with the minor, C always has to do with the foci, the plural version of focus points. And then 3 statements that, again, I've already made them, but I just want to point them out one more time. The vertices are always going to be A away from the center. The endpoints of the minor axis are always going to be B away from the center. And then lastly, the foci are always going to be C away from the center. 3 important points to remember as we move into some examples for ellipses.